So let's just do an example, and hopefully you'll start to see how this works. Let's find the solution to the equation x squared minus 2 equals 0. Now we know the answer to this, right? What's the answer to this? No. What's the answer to the problem? Like if we were in college algebra class, I said solve x squared, square root of 2, negative square root of 2, right? Well, that's how we would do it algebraically. Take square root, plus or minus, and then on a calculator you get plus or minus 1.414, something like that, right? Blah, 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 blah. Yes? Okay. But what if it's an equation we can't solve, but like this? Well, have we ever run across an equation that we can't solve in this class? Like a little while ago, right? Okay. So we could do it on the calculator, as some of you did. Y'all came up here and I showed you how to do it. Now, how is your calculator doing it? It's doing this. Okay, so behind the scenes, your calculator is finding this sequence right here and watching it converge to an answer. And we'll see it when we work it out right now. We'll see it start to converge to 1.414. So the first thing we have to do, folks, is we have to guess what the answer is. So let's just guess. Well, we're going to do 3 because it'll match the picture that I did here, because I did 3 to start, and everything will match up after that. So I want to stay with that. So I'm going to let x0, that's going to be my first point. I'm going to let x0 be equal to 3, and that's my guess. Now, according to the formula up here, if I replace the right side of the equation here with x0 minus f of x0 over f prime x0, that should be equal to x sub what? 1. So if this n is 0, this over here is n plus 1 would be 1. So the next x value, the x sub 1, should be whatever that computes to be. If I replace this n here with 0, that with 0, that with 0, then this side becomes 0 plus 1 would be 1. So now I have the 1 here, I've got 0, 0, and 0. Now, what is f in this problem? What's the function? It's the left side of this equation. It's f. This is our f of x. While we've got it here, if f of x, if f of x is x squared minus 2, then what's f prime of x? What's its derivative? 2x, right? Now we need that because I'm about to come back over here and compute x sub 1. It will be x sub 0. What was x sub 0, everyone? 3 minus f of 3. What's f of 3? Plug 3 into the function. 7, right? 9 minus 2. So 7 over, plug 3 into the derivative, you get 6. What's 3 minus 7/6? You have to get a common denominator there. (11/6). And what is that as a decimal? Just to get an approximation. 1.83. Now I'm not going to use that, but the reason why I wanted you to see that is because I want to come back up to my picture. I wanted you to see that the next point that I get, I started with 3. This next point right here looks like it's about 5, 6, 7, 8, 1.83. So that point is coming from that computation. Now what we do is we use that to get our next point. Understand how this is flowing? So what should my next one say here? X sub 2 equals 11/6. We are not going to use the decimal, okay? We're going to use the fraction. 11/6 minus, how about f of 11/6? We'll compute it in a second. F of 11/6 over f prime of 11/6. There's not a whole, this isn't a problem like, cut the sphere in half and notice these triangles and all that. This is very mechanical. These problems is just plug and chug. You just got to know how to apply the formula. So this is 11/6 minus, 121 over 36 minus 2. I'm getting 49 over 36 over 22 over 6. And then you can flip and do all that stuff. I get something like this. 11 over 6 minus 49 over 132. Which is 193.13 or over 132. Positive. Which is approximately, man, why does it keep doing that? This is approximately 1.462. Any question where any of those numbers came from? I mean, I skipped some steps. I just had my calculator do it, but you could simplify those fractions, hopefully. And then, if you look back at this here, my second point was right in here, right? So I'm going to zoom in on it. It should be really close to 1.4. What was it? 1.4 something? It's right in here. So let me really go in here. Yeah, here's 1.41. So here's 1.45. Here's 1.46. What do we say? 46 what? 2. So yeah, it's pretty close, right? And now we do that again, and we come over here. And look how close we are on the third application of Newton's method. On the third application, look how close we're going to be to the true answer. Right? And then you could keep going. I'm not going to... Did I have it compute? I think I did. Fourth. Yeah, there's the value. At the 4 time, we're not going to do anymore, okay? We're going to stop here. But if we did it again, this next one would be 1.41498, which is really close to what square root of 2 is on your calculator, right? If we go again, 5th iteration, we're 1.414213. See, we're ready. For most books, 1.414 would be sufficient. Now, depending on if you're building let's say a deck, a wooden deck in someone's backyard, your tolerances don't need to be within 1,000th of an inch. If you're building an aircraft, then we're talking about tolerances that are really, you would have to go further than this, perhaps. But that's okay, just reiterate one more time. Understand? But it gets there. The whole point of Newton's method is it gets there fast. There's even better methods than Newton's method out there also. Yeah, we're good. I think, did I assign the homework problem out of that? 4.6? Who has their book? I don't have mine with me. Thank you. Okay, I'm going to say for 4.6, why don't you try number 7? And number 13. 13 is a good one because on 13, here's the equation. There's the equation. Four or five. Did I not get 4 or 5? I think I did last time. I'll put it back up there. Here you go, Les. See, because number 13, that's the equation. And that's pretty similar to what we got stuck on, isn't it? So yes, we know the calculator can do it, but now we're showing with Newton's method how it's done. I would, if we were all fresh and feeling good today, I would show you where Newton's method came from. It's in the book. I doubt you all feel the attention span right now to have me show it to you, so I'm not going to. But make sure that you work these out, okay? Because I will ask you a Newton's method problem on the final, because I think these are easy points. I mean, this should be easy points on a problem like this. Hopefully. It's just plug and chug. Last class, we had the homework assignment. Let me see if I can find it. Okay, there's the homework from 4 or 5. So for next class, you have no videos to watch, all right? All you have to do is get caught up on your homework. So focus on all those, the graphing, the sketching, the graphs, if you haven't done those. 4.5, those are all word problems, optimization. 4.6 is going to be the Newton's method, 2 problems. Come in on Monday. We'll finish up 4.7, and we'll talk final. And maybe a little 5.1, we'll see. Quiz from last time. Yep, I'll take that. Just set it here. And everybody that's here gets 100 today also. I'm just going to note that. I'm just going to count 100, then on top of that. That's all right, just like that. Everyone have a good day. I'm going to let you go.